Welcome back, students. Hope you all are fine. In the last class, we studied about the laws of exponents, and today we are going to see the questions related to the laws of exponents. The very first question, 3 to the power 3 by 4 multiplied by 3 to the power 1 by 4. This is a very simple question. You have studied that whenever it is a to the power m and same thing has another power, then what happens? Then the base remains the same and the powers add up. You have studied this form, a raised to the power m multiplied by a raised to the power n. This becomes a raised to the power m plus n. We are given 3 raised to the power 3 by 4 and multiplied by 3 raised to the power 1 by 4. So this is of the same form. The base will remain same. The powers will add up. 3 by 4 and plus 1 by 4. The denominator will be 4, 3, 1. This becomes 3 to the power 4 by 4. That is 3 to the power 1, and 3 to the power 1 is 3 itself. The first question is very easy. Moving next. Second question is 64 raised to the power 1 by 3. See, you have studied a raised to the power m and that raised to the power n. This becomes a raised to the power mn, isn't it? You are given 1 by 3 in place of this n. It is 1 by 3. So whatever will be this value, you will be having 1 by 3 and this m will multiply by 1 by 3. If we get this 64 in the form of a number that has its power as 3, then this m will be 3 and 3 multiplied by 1 by 3, 3 will be removed. It will be a to the power 1, that is a. So can we find 64 in the form of something raised to the power 3? Let's see. We have 64. First to the prime factorization of 64, and let's see what are the numbers, what are the prime numbers hidden inside it. The unsplittable prime factors: 2 32, 2 16, 2 8 ja, 2 4 ja, 2 2 ja. So 64 can be written as 2 into 2 into 2 into 2 into 2 into 2. So we have 6 times 2. If you take every two twos as one pair, you will be having 3 pairs of 2. So if we write this as 4 into 4 into 4, what we are going to get? We are going to get 4 raised to the power 3. Clear? So 64 can be written as 4 raised to the power 3. Now the question is, this is your question. You can write it as 4 raised to the power 3 and that raised to the power 1 by 3 as per your question. This will become 4 and the power of power, both the powers get multiplied. 3 multiplied by 1 by 3. 3 and 3 will be removed. You will get 4 to the power 1, that is 4. So these are very simple questions based on laws of exponents, and laws of exponents are directly applicable here. Next is 125 raised to the power minus 1 by 3. If you convert it, this will be of the form, this is just to make you understand. Minus is inversion. You can invert it inside, you can invert it outside also. Suppose you can write this like this also. 1 by 25 raised to the power 1 by 3. This will be your cube root of 125. So this is for your understanding. Let's solve this question. Even without putting this square root sign, you can solve this. See, 125. You cannot divide it by 2, you cannot divide it by 3. 5, 2, 7, 1, 8. You cannot divide it by 3. 4 is also not applicable. Next one is 5. And 5, 25 ja, 5, 5 ja. So it is a cube of 5. 5 cube. Again, just like in the previous question, 5, 3 into 1 by minus 1 by 3. 3 is removed. You get 5 raised to the power minus 1. And 5 raised to the power minus 1, anything raised to the power minus 1 is the inversion of that number. This number will get inverted. A to the power minus 1, what it is? It is 1 by A. 5 raised to the power minus 1, what it is? It is 1 by 5. So 1 by 5 is your answer. Hope it is clear to all of you. Coming to the next question, 0.00032 raised to the power minus 2 by 5. Here 5 is what? 5 is the fifth root and 2 is the power, and minus sign represents the inversion, 1 by. So we have one 1 by case, we have one square case, and we have one fifth root case. Three cases are hidden inside this minus 2 by 5 as exponent. So first of all, what is this? In this form you can never solve this, so you have to convert it into another exponential form so that powers will cancel each other, or if not cancel each other, it will be some simpler form. Say 0.00032. What can you write this? If you want to remove this decimal to one place, you will have to multiply it with 10, that is 10. 2 place, another 10, that will be 100. 100 is 1 and 2 zeros. Similarly, 3 places, 1 more 0. 4 places, 1 more 0. Till now you will get 3.2, but we do not want 3.2, we want 32. We want this number free of decimal. So shift this decimal to after 2. So 1 more 0. How many zeros? 1, 2, 3, 4, 5. 5 zeros. That means you are having 10 to the power 5 here. Clear? 10 is 10 to the power 1. 100 is 10 to the power 2. Number of zeros equal to the number of powers over 10. So we had 5 zeros, 10 to the power 5. And you also need to divide it by the same. This will get consumed in removal of this decimal, but this will continue. So you can write this number as 32 by 10 to the power 5. Is it? So this can be written as 32 to the power 10 by 5. So this number is 32 to the power 10 by 5. Now see 32. If you do the prime factorization of 32, you will get, see, we have another method. You don't need to do this type of work. You can simply do as I am doing here. 2. What is left? 2 multiplied by 16. So 2, now 8. Now what is left? 4. Now what is left? 2. 2 to the 4 to the 8 to the 16 to the 34. So if you first take this 2, what will be left? 16. So keep this 16 in your mind. Write down whatever comes here and keep what is coming down in your mind. So 2, what is left? 16 is left. Again 2, what is left? 8 is left. Again 2, what is left? 4 is left. Again 2, what is left? 2 is left, and 2 is coming down. So in this way you can also, if you find it difficult, you can carry on with this method also. I have told you 4 ways, out of which 2 ways directly give you this type of form. Factor tree, you remember? 32 can be split up into 2 into 16. This 2, 8, 2, 4, 2 and 2. You carry on splitting the branches until you get a prime. You get a prime number over here, you stop this part. You carry on with this part. You get a 2, you get 8. You leave this up to here because you have got a prime number. You carry on with this one, 8. And likewise, you get 2 into 2 into 2 into 2 into 2. So using this factor tree also you can find out the prime factorization and the prime numbers like this that make this number 32. So it is what it is, 2 to the power 5. So there are various methods from here also. So you can write this 2 to the power 5, and you have 10 to the power 5, clear? And this had power of minus 2 by 5. So this will also have a power of minus 2 by 5. If you see this is what? A to the power m and divided by a to the power n. Sorry, this is what? This is a to the power n, and here is another number b and power is same m. This form, a to the power m divided by b to the power m, power is same and bases are different. What you do? You put it like this. You put a same power. This will be a to the power b whole to the power m. So you can write this as 2 to the power 10 whole to the power 5. 2 to the power 10 whole to the power 5. And what you have here? Power is minus 2.5. Power gets multiplied. So this will get multiplied. Minus 2 upon 5. 5 will remove each other. You will have 2 by 10 to the power minus 2. Now we have removed the fifth root. Only 2 things are remaining. One is inversion, another is a square. You can perform either operation in your first step and the other one in the second step. So whatever you want to do, let's first invert it. 2 by 10 to the power 2. This will become 1 by 4 by 100, isn't it? One divided by 4 by 100, and denominator of denominator, it becomes numerator. So 100 will come in numerator, 4 will remain in denominator. Why this denominator of denominator comes in numerator? See, we have something like this. One fraction is a by b, another fraction is c by d. This you can write as a by b divided by c by d. Now, whenever you divide this a by b from c by d or any number of such form, and you remove this sign of division and apply sign of multiplication, you reverse this. D becomes your numerator and C becomes your denominator. So it becomes A into D by B into C. The denominator of denominator, this is the denominator, and the denominator of denominator is D. D will go to the numerator side. D has gone to the numerator side. And the denominator of numerator, this part was numerator and this denominator was b, b will go down. So if it is a fraction and something is written in down, it will go this down, and here it is already in the denominator, that is down position, and something is further down to it, it will come up as a numerator. Hope it is clear to you. If not clear, you can pause this, reverse the video, or rewind the video and again listen and again understand. Try to understand this. So this has become 100 by 4, 100 25 times. So what we get? We get 25, and this is your answer. First we remove this fifth root, then we used up this inversion, and we have also done a square, so we have used this complete part, and what we got 25 as our answer. This is clear, this is clear, this is clear, and this is also clear. Now fifth one, 14641 0.25. First of all, this may cause problem to you or trouble to you because you have not studied or solved any such problem with 0.25 as power. But this you can easily convert it into the form p by q. 0.25, again by the same way as I have told you so many times, to bring this you need 10 to the power 2. 10 to the power 2 will be divided. This will get consumed. This will remain. You can write it 25 by 10 to the power 2. That is 25 by 100. 25 by 100 is what? 1 by 4. So 0.25 is nothing but 1 by 4. You can write this as 1 by 4. Remember, do not write whenever I rub something, you do not forget that step. Do not directly jump to this form. You need to convert it. I am rubbing it each time just because of the limitation of the space. So this is 14641 and the power is 1 by 4. Now we need to split this number. How can we do this? Do the prime factorization, but it is 14641, a large number, larger than you have solved in the last 4 questions. Can 2 divide it? No. First you need to know the divisibility test for 2, 3, 4, 5, 6, 7, and the next prime number is 8 is not prime, 9 is not prime, 10 is not prime, 11. So at least you must know the divisibility test for these numbers 2, 3, 4, 5, 6, 7 and 11 at this stage 9th class, so that you can solve a lot of problems. For 2 divisibility test says if a number has 0 or even number at the end, 1 is neither 0 nor even number, you cannot divide it by 2. For 3, sum of numbers should be divisible by 3. Sum of numbers, see, 1 plus 4 plus 6 plus 4 plus 1. It becomes 5 and 6, 11, 11 and 4, 15 and 1, 16. 16 is not divisible by 3. So this number is not divisible by 3. For 4, the last two digits should be divisible by 4. 41 is not divisible by 4. For 5, the last two digits, for 5, the last digit should be either 0 or 5. 1 is neither 0 nor 5. It is not divisible by 5 also. So 2 is failed, 3 is failed, 4 is failed, 5 is failed, 6. A number is divisible by 6 only when it is 6 is not also a prime number. But okay. But you must remember the divisibility test for 6. If a number is divisible by 2 and it is also divisible by 3, then only it will be divisible by 6. It is neither divisible by 2 nor by 3, so not divisible by 6. And 6 we have not to consider here, because we are only looking for a unsplittable number. Unsplittable number is a prime number. So next is 7. The divisibility test for 7 says you take this last digit, the digit at ones place, twice it. 1 multiplied by 2 is 2. Take the remaining portion, that is 1, 4, 6, 4. Now subtract these two. 1, 4, 6, 4 minus 2. It is 1, 4, 6, 2. If this number is divisible by 7, or this number is 0, then the given number is divisible by 7. See, if we say 147, the last digit is, or the digit at ones place is 7. So 7 multiplied by 2, we get 14. The remaining digits are 14. Remaining is 14. If you take the difference between them, the difference is 14 minus 14, that is 0. So if the difference is either 0 or it is divisible by 7, then the number will be divisible by 7. Here we get 0, so this number is divisible by 7. If it was not 0, if it was something else, suppose 14, the numbers were some different numbers and you get 14 is divisible by 7, so the number was also divisible by 7. So either the difference should be divisible by 7 or the difference should be 0. Either the difference of the numbers which two numbers? Number at twice the number at the ones place, and the remaining numbers. If the difference of those two is either 0 or divisible by 7, then that given number is divisible by 7. So that is the divisibility test for 7. Here this is not divisible by 7. How? See, 1462, if you divide it by 7, 7 2s are 14, and how will you divide this 62? This is not going to divide by 7. This number is not divisible by 7. If you don't want to remember this divisibility test for 7, you can simply try this 14641. 7 2s are 14, 6 4 7 9 are 63, 1 and 1. Can you divide this 11 by 7? No. 7 1 ja 7, 4 is left. Okay, you will have to put a decimal over here. It cannot be divided perfectly divided. It cannot be perfectly divided, so 7 is also ruled out. Next is 11. the divisibility test for 11 says if there is a number, suppose take this number for example, take all the numbers at the even odd places and even places. This is 1, this is 6 and this is 1. Add them, what do you get? 1 plus 6 plus 1, it is 8. And the sum of numbers at the even places, first even place this, second even place this, 4 plus 4, 8. See, if you subtract them, it will be 0. So this number will be divisible by 11. If the sum of digits at the even places is equal to the sum of digits at the odd places, then the number is divisible by 11. This time we have sum of digits at the odd places as 8 and the sum of digits at the even places also as 8. So this number is going to be divided by 11 perfectly. Remember the word perfectly, it can perfectly divide this number. So divide it by 11. 1 4 6 4 1, 11 1 ja 11, 3 6, 11 3 ja 33, 3, 4 will come down, 11 3 ja 33, 1 is remaining, 1 will come up from here to this position and 11 1 ja 11, remainder 0. So you can write it as 11 into 1331. Now this 1331, sum of digits at the odd places 1 3, it is 4. Sum of digits at even places 1 and 3 4, they are same, it is again divisible by 11. So again divide 1331 by 11. 1331, 11 1 ja 11, 2 is remaining, 2 3 23, 11 2 ja 22, 1 is remaining, 1 will come over here, 1 ja remainder 0. So you can further write it as 11 into 121. 121 is what? 11 into 11. So you find it as 11 into 11 into 11 into 11. So if you multiply 11 4 times, you get this number. You can write it as 11 to the power 4 whole to the power 1 by 4. And anything raised like put like this, a to the power m to the power n, it becomes e to the power m into n. The powers get multiplied. So here also powers will get multiplied. 4 will get multiplied with 1 by 4. 4 into 1 by 4, 4 and 4 will cancel each other. You will have 11 to the power 1 and this is nothing but 11 itself. So the answer is 11. Clear? You have done this also. Only 2 questions are left. Question number 6. This is an easy question, but all you need is a little bit patience. Maths is always about solving something. Maths never make anything complex. In mathematics, we always try to simplify the things. So for simplifying this thing, you will need a little patience because you find so many x to the power and this roots are there. So by looking at this question, you should not worry about it, rather you should have some patience, because for solving this you will get some marks and that marks deserve something. All that asks is your patience. You show your patience, you will solve it correctly and you will get full marks. In maths, it's easier to get full marks. Only show your patience and in such questions, and just apply a very little brain. See, it is fifth root of x to the power 4. We will solve it step by step. Then fourth root of x to the power 3. This is fifth root, so x power 4. This is fourth root, so x power 3. And it will go on. Cube root of x square. And this will carry with it square root of x. Now, this, what can you write this? You can write this as x to the power 1 by 2, isn't it? So write it x to the power 1 by 2. Let's make it simple, 1 by 1. X to the power 1 by 2. Now in the next step, you have a to the power m into a to the power n. What you will do? You will perform the operation of a to the power m plus n. So you will add 2 and 1 by 2. What it will become? Denominator will be 2, 2, 2 is a 4, and plus 1, it will become 5 by 2. So let's perform this. Fifth root of x 4, fourth root of x cube, then inside it there is a cube root of x raised to the power, how much? If you add them, you get 5 by 2. 5 by 2 is 1, 2.5. This is also 2 and this is half, 2.5 also. This is also 2.5, this is also 2.5. Now, fifth root x to the power 4, fourth root x cube, this x to the power 5 by 2, and if you remove this, the power will be this time 1 by 3. This is a cube root, so power will be 1 by 3. Now power of power, it will multiply. If you multiply 5 by 2 into 1 by 3, what do you get? You get denominators multiply together 6 and numerators multiply together 5 by 6 you will get. You can see the length is getting shorter. Initially we had 1, 2, 3, 4 roots. Now we are having only 1, 2, only 2 roots. See? So it will be fifth root of x to the power 4, fourth root of x to the power 3 multiplied by x to the power 5 by 6. Clear? Hope there is no problem till now, and there won't be any problem also, because you are wise enough to see what is going inside this. So now this we have a to the power m, and again you have a to the power n. It will be a to the power m plus n. So you have x to the power 3 and x to the power 5 by 6. This is division. So what it will be? It will be 3 plus 5 by 6. And 3 plus 5 by 6 is what? 3 plus 5 by 6. What will be the denominator? Denominator is the LCM. See, this is having no denominator, so denominator will be 1. Let me erase this. If you have a number like this, See, I am telling you just because if you have forgotten this, that you have studied in your previous classes, it should not be a hurdle for you to solve questions in class 9th, because in the next year you will be going in 10th, and there will be a bigger problem for you if you do not understand it here. So this is 3 has no denominator. Denominator will be 1. Now we will take a denominator. What will be the denominator? The denominator will be the, in such cases, when we add a fraction or subtract a fraction, the denominator is the LCM of the denominators. We have 1 and we have 6. The LCM you have to take. The LCM will be 6. So our basic motto is that there should be some number here which this can also divide and this can also divide. If you have 2 to the power 3 and you have to add 5 to the power 2, denominator will be 6, because 6 is the LCM of 3 and 2. Why are we taking the LCM? LCM is lowest common multiple. See, the basic motto is that 3 can also divide it, 2 can also divide it. So even if you take 12, 3 can also divide it and 2 can also divide it. But this is not the smallest one, which both of these can divide. 6 will be the smallest one. 6 will be that common multiple. That will be the common lowest number. Lowest common multiple. That's why it is called LCM. Lowest common multiple. It is common. It is common. It is lowest. And it is a multiple. So it is the LCM. Now next what we do? 3. If you divide 6 from 3, 3 can divide 6 in 2 times. 3 2 ja 6. 3 2 ja 6. So this 2 ja, you multiply it with the numerator. It will be 4. And 2 3 ja 6. 2 3 ja 6. This 3 will multiply with its numerator. Then this will become, this plus sign will transfer. First operation this, we get 4, plus sign will come this place. Then this next operation, 2 3 ja, so 3 will multiply with 5, it will become 15. So 4 plus 15, we get 19. 19 by 6 is the solution for this. 2 by 3 plus 5 by 2. So what is the LCM here? 6. 1 6 ja. So 6 will multiply with 3, it will give you 18, and 6 will multiply will divide 6 one times. 1 will multiply with 5, you will get 5. 18 and 5 is 23 upon 6. So if you add them, 3 and 5 by 6, you will get 23 by 6. So you can write from here, it will be fifth root of x to the power 4, fourth root x to the power 23 upon 6. See how much smaller it has become. Only 2 roots are now left. That's why I told you you need a little patience to solve such questions. So we have fifth root of x to the power 4. Now this x to the power 23 by 6, since it is a fourth root, so what should we write? We should write 1 by 4. Step by step we are removing the roots. This power multiplied by another power, a to the power m to the power n, the powers will multiply and become a to the power m into n. So the powers will multiply. The powers multiplied. If we multiply the powers, 23 by 6, 1 by 4, what it will become? It will become 23 by 24, isn't it? So you have 23 by 24. Fifth root, x to the power 4 into x to the power 23 by 24. Now you can write this as fifth root x to the power 4 and x to the power this a into a to the power m into a to the power n. The powers will add up. 4 plus 23 by 24. Fifth root of x to the power, denominator will be 24. 24, it has denominator 1. So 1, how many times? 24 times. 24 4 ja. 24 4 ja is 96 and plus 23 here. This will give you fifth root of 6 and 3, 9, and 2 and 9 is 11 divided by 24. Now only one root is left. X to the power 119 by 24, and fifth root it is, so you can write it 1 by 5. Now power of powers will multiply. 119 by 24 into 5. How powers multiply? See, it is numerator, what is denominator? The numerator will multiply with numerator and denominator will multiply with denominator. Sorry, this is 1 by 5. Numerator will multiply with numerator and denominator will multiply with denominator. It will become 119 multiplied by 1. Anything multiplied by 1 is the number itself. 24 into 5. 5 4 ja 20. 0. Carry 2. 5 2 ja 10 and that 2. 12. So this is your answer. X to the power 119 by 120. So you have solved this also. Next is 5 raised to the power x minus 3 multiplied by 3 raised to the power 2x minus 8, and this is equal to 225, and you have to solve it. All these questions are done and only one question is left. Five x to the power minus 3 into 3 2x minus 8 equals to 225. This is what? This is your question. See, it is in the form of its power. This 3 is also expressed in the form of its power. So it's better if we can write this 225 in the form of its power. So let's take the prime factor. 2, no, 2 cannot divide it. 3, 4, 2, 5, 2, 7 and 7 to 9, yes, 3 can divide it. 3, 7 ja 21, carry 1, 1, 5, 15, 3, 5 ja 15. Again 3, 25 ja, 5, 5 ja. So you can write this as, in the next step you can write it 2x minus 8 equals to 3 to the power 2 into 5 to the power 2. Isn't it? Yes. See, in this number 225, this 3 is available only 2 times. Inside this number 225, there are only 2 times 3. 3 is available only 2 times and 5 is also available only 2 times. There are no more 5 and there are no more 3's inside this number 225. So if it is expressed in the form of 5 and 3 only, 5 has the power of x minus 3, this can be none other than the power of 5 here. Only two 5s are here. So if you compare this, you can get x minus 3 is 2, and for 3 we have power 2 here and 2x minus 8 here. So the base is remaining same, powers will also remain same. 2x minus 8 is equal to 2. From here you get x equals to 2 plus 3. Transposing this will change its sign from minus to plus. You will get 5. This 2x minus 8 equals to 2. This will give you 2x equals to 2 plus 8, that is 10. And this will give you x will 2 is multiplied, so 2 will be divided here. You will get 5. So the value of x is 5. Clear? Next question. Hope it is visible to you clearly. Root x to the power minus 2 by 3, root y to the power 4 divided by xy out of a square root, out of which y is having the power minus 1 by 2, and square root x to the power minus 2, y to the power 3. See, sum is in the form of, there are mixed roots are also there and the exponents are also there, so it's better we convert it into the exponential form so that our way of solving it will be easier. You can easily solve it. This, how can you write this? X to the power 1 by 2, and after you write it as 1 by 2, the power will be minus 2 by 3, and power of power is multiplied. You can write it in 2 steps also. You can first do this, then do this, and later on in the next step you can multiply it. See, for your exams, never escape any step. For board exams especially, if you are given a question of 6 marks and you can see it, visualize it, that it is going to lead you to some place, and you just write it in 2 lines, this is obviously going to reduce your marks. Solve it with proper steps. There is no hurry. Rather, if you solve it, you are in 9th class, you solve it step by step. If you have any issue or any problem, or you get stuck somewhere, you can easily cross check where you are stuck. It will be easier to detect your errors also. So no need to hurry up in this 9th class. Y to the power 4, and this is 1 by 2. I am skipping one step. You can take one more step. Division. X y minus 1 by 2, and this whole has a power of 1 by 2 because the square root is there. Again, x minus 2 and y 3, this also has a square root. This you can write as, see, x to the power minus 2 by 6. This 2 is here as denominator and this 2 is here as numerator. This will cancel each other. So it will become minus 1 by 3. 2 2s are 4. Y square. Denominator. You have also studied the property AB to the power m. It becomes the individual power also after this separates. This is like a child. These are parents. If the parents separate, father also carries the child. The mother also has a right over the child. So A will also have m and B will also have m. So this 1 by 2 is going to get associated with this x also and this y also. So when this gets associated with x, x was alone. For y it is minus 1 by 2 and 1 by 2, minus 1 by 2 and 1 by 2, and again x minus 2, 1 by 2 and y 3 into 1 by 2. What do you observe? X to the power minus 1 by 3, y to the power 2 divided by x to the power 1 by 2. Let's make x together. This is x to the power minus 1. We have a into b into c into d, all are multiplying with each other. So you can put a c together and b d together. This is not going to affect. This is y minus 1 by 4. Again another y is 3 by 2. X minus 1 by 3, y to the power 2. X powers will add up, 1 by 2 and plus minus 1. For y minus 1 by 4 and plus 3 by 2. Continuing from here, x minus 1 by 3, y 2, x 1 by 2 minus 1, 2 is the denominator, and I think I should write like this, it will be easier for you to understand. So, and this has 1 as denominator, 1 over here and minus 2 over here, y 4 is the denominator, 4 1 ja, minus 1 is there, and plus 2 2 ja and 2 3 ja 6, so 6 is here. This is x minus 1 by 3, y 2, x minus 1 by 2, y 5 by 4. Take x together, x minus 1 by 3, x minus 1 by 2. Take y together, square by y 5 by 4. This is equal to x a to the power m by same a to the power n. What it becomes? A to the power m minus n. The powers are subtracted. Minus 1 by 3 minus 1 by 2, and y 2 minus 5 by 4. This will give you, this will be plus. So plus sign you always try to write it in the left, it will be easier for you to understand. Plus 1 by 2 minus 1 by 3, plus 1 by 2 minus 1 by 3. Y is 4 as denominator, 2 2 ja, 2 1 4 ja and 4 2 ja 8, minus how much? 5. Here what? 3 2, no not 3, here it is 6, 2 3 ja and 3 1 ja, 3 minus 3 2 ja, y how much power? 3 by 4, and x is having power 1 by 6, y is having power 3 by 4. So this is your solution. X is having power 1 by 6 and y is having power 3 by 4. Moving on to the next question. Question number 9. So your next question is 2 to the power x minus 1 plus 2 to the power x divided by 2 to the power x plus 1 minus 2 to the power x, and this is equal to 3 by 2. You have to solve it. See what you see here. 2 has power of x, 2 has power of x, 2 has power of x, 2 also, 2 here also has a power of x. If you try to obtain something that can reduce it to a simpler version than this, and you can reduce it by taking something common. There is no other way that you can reduce this form. So what common you can take? In this form you cannot take anything common. So let us convert it to our desired form. You can write it as 2 to the power x into 2 to the power minus 1. Obviously you can write 8 to the power m into a to the power n. It becomes a to the power m plus n. And when you are given a to the power m plus n, you can also split it into a to the power m into a to the power n. We are given x to the power or 2 to the power x minus 1. If we write it as x to 2 to the power x and 2 to the power minus 1, this power will add up and you will get 2 to the power x plus minus 1, that is 2 to the power x minus 1. So this 2 to the power x minus 1 can be split it as 2 to the power x into 2 to the power minus 1. That is what we have written here. This will remain same. This is already a simpler form. 2 to the power x into 2 to the power 1 or anything. We never write this 7 to the power 1 because it is already 7. So write it as 7. So 2 to the power 1 you can leave it as 2 also, and minus 2 to the power x. See, is there anything common? From the numerator you can find 2 to the power x is common. So let us take what is common and try to make it easier. In maths we always try to make the difficult things simpler. 2 to the power x is common. We get 2 to the power minus 1, and there is one plus sign over here and plus 1 because this will multiply with 1 and will give 2 to the power x. Similarly, in the denominator also, take 2 to the power x as common, you get 2 and 1 is here. Now this becomes 2 to the power x multiplied by something. In denominator also 2 to the power x multiplied by something. We have a into b, and again we have a into m or n or m, anything. So you find a here and a here, you can remove it or this will cancel out each other. You will be left with b by m only, isn't it? That is what happens. So here also 2 to the power x will cancel out each other. And you will get 2 to the power minus 1, it is 1 by 2, and plus 1 divided by 2 minus 1 is 1. So you can leave it or you can write it you can leave it in the next step, because to show it is also important that this has happened, otherwise your marks will get deducted at the school level. So you can write it this in the next step. Take the denominator as 2, and this will be 2 1 ja, so 1, and 1 2 ja, so 2. What you get? You get 3 by 2. This is what your RHS was. Thus, we have proved that this is equal to 3 by 2. Isn't it? You start with, or you proceed with LHS, and after you get this, you write it as equals to RHS, and hence proved. Do not write like this handwriting. Write in a better handwriting, your original handwriting. This class is only to make you understand the things. So question number 9 is also done. Next will be your question number 10. This is your next question. A to the power minus 1 divided by A to the power minus 1 plus B to the power minus 1 plus another term A to the power minus 1 divided by A to the power minus 1 minus B to the power minus 1. This is given, and you have to prove that this is equal to this, your LHS, your RHS. What is in RHS? 2B square by B square minus A square. If you go with this LHS and you are correct in your approach, you are obviously going to get this RHS. This is not very difficult. What is common? This A to the power minus 1 and A to the power minus 1, both are common. The same thing is, the same pattern is over here in both the denominators, only there is a difference of sign. One is having plus sign, another is having minus sign. So do you see any minus 1 or minus 2 or minus sign denominator here in RHS that is you are going to have? No. So there is no need of this minus 1 power. So in any case, anyhow, you have to remove this minus 1 power or any negative power. If you are not going to do this, you will never come to this form, because it does not have any minus power. So there is only way to remove this. What is that way? Convert this 1 by A plus 1 by B plus 1 by A minus 1 by B. This will give you 1 by A will remain as it is. Denominator will be AB, because this is the LCM. Why this is the LCM? Because if you take 2AB, A can divide 2AB, B can also divide 2AB, but this is not the lowest one. Lowest one is this, only AB. You can take 3AB, 4AB, 5AB, anyhow it is, both of them are going to divide this. But the smallest one, but the lowest one, that is the lowest common multiple, will be this AB only. So take AB as denominator, A, B times A will multiply this. If you multiply A with B, then only you will get this. So B times B will multiply with 1 is B. Same with this B also, it will be A. Next term, 1 by A divided by, here also AB will be, and B minus A. Now you see A 1 by A, this is division. Division when converts into multiplication, denominator becomes the numerator, and that is denominator of denominator is the numerator. So it will become, this whole part is getting divided. See, you see here, this whole part is getting divided. B plus A by AB is divided, going to divide it. So when you this is what? This is this form, b plus a by ab. If you are going to convert this division into multiplication, what you are going to do? AB will come up and b plus a will come down. So AB is going at the top. AB is going at the top, and this b plus a will remain here. Plus this is one term. We have proceeded for this, then plus sign over here, then 1 by a. Again, what you have done in this, same you will repeat over here also, a by b, b minus a is here. From this you get ab by a can cancel in, a can cancel a. So you get b by b plus a and plus b by b minus a. Again, what will be the denominator? B plus a into b minus a. Then only this can also divide and this can also divide this denominator. B plus a, how much time? B minus a times. So this b minus a will come over, will multiply with this b into b minus a, plus sign, b minus a, b plus a times. So this b will multiply with b plus a. Moving on from here to this place, solve it. This is b square and minus ab plus b square and plus ba divided by a plus b into a minus b. What it is? It is a square minus b square. So if two numbers are getting added and same numbers are getting subtracted, if one number is getting added with another number and it is being subtracted with the same number, then what we get? We get the square of first number minus the square of second number. So we have square of first number and minus square of second number. Denominator we have obtained. If you obtain the numerator also, our RHS will be right. We will reach to our destination. Let's see, minus AB and plus BA, it is same and having the opposite sign, so they will cancel each other. See, here it is AB, here it is BA, it does not matter. You write 2 into 3 or you write 3 into 2, both are same. So you can write BA as AB also, you can leave it as BA also, it does not matter, it will cancel out. And what you are having B square and one more B square, this 2B square, and in denominator B square minus A square. So you proceeded with LHS and you got this as RHS. This RHS was the same and hence proved. So question number 10 is also done. This was a very easy question. What we will do next, we will move on to the next question, to question number 11. So we are going to move to question number 11. This is your question number 11. It says x to the power p by x to the power q power p plus q, x to the power q by x to the power r, power q plus r, x to the power r by x to the power p, power r plus p. See, you can solve it in more than one ways. You can either write x to the power p by x to the power q, and since it is a to the power m plus n, you can write a to the power m and then a to the power n. So you can write it again as this power p and same thing to the power q and proceed. You can also write it as x to the power p minus q to the power p plus q and so on. And in the next step, this a minus b into a plus b, this will give you x to the power p square minus q square, and this will happen with the same x. This will happen with the x in this case also, q square minus r square, and again r square minus p square. And since this is a to the power m and a to the power n, powers will add up, and when you add all these, p square, well, you will get 1 minus p square, r square plus r square minus, then in this way all the powers will get cancelled. Ultimately you will get x to the power 0, which is 1. So you can solve it in any ways. Whichever way you want. If we do it like this, q x to the power r, q x to the power q, x to the power r and r, then x to the power r, x to the power p, one time r, x to the power r, x to the power p, and this time p. So what you get? You get x to the power p square by x to the power qp multiplied by x to the power qp or pq, anything you write, x to the power q. See, x to the power qp and x to the power qp cancel here only. X to the power q square, x to the power rq, x to the power qr, x to the power r square, x to the power qr, x to the power qr, x to the power r square, x to the power pr, x to the power rp, and x to the power p square. X to the power p square. X to the power p square you have denominator, x to the power p square you have in numerator, x to the power q you have in yq, q and q square it is, x to the power q square and x to the power q square, x to the power r square, x to the power r square, x to the power pr and x to the power pr or rp and pr are same. You get everything get cancelled and you are having only 1 at the end. So this question is also solved. This was your question number 11. So I told you 2 methods through which you can solve this question. One is this way, another was a plus b into a minus b, a square minus b square, p square will cancel minus with minus p square, q square with minus q square, and r square with minus r square, and ultimately you will get x to the power 0, and x to the power 0 but is nothing but 1 itself. So next question is question number, it was 11 I think, so it will be 12. This time we are taking two questions, question number 12 and question number 13. Question number 12 says to arrange these in descending order. Descending means larger, then a smaller, then a smaller, then a smaller, then a smallest. This is your descending order. In descending, D for descending, D for decreasing. It will be in the decreasing fashion. And another is ascending order. This is your ascending order. You keep on rising. So at the beginning, the smallest number will be there. So ascending, and this one is descending. You are descending down the stairs. That means you are going down from third floor to second floor to first floor to ground floor. So in this case, you have to arrange it in descending order. First, in any of these cases, what is the key thing that you need? The key thing that you need is the value. Which of them are larger, which is smaller than which number. Then only you can arrange them either in ascending or descending. So let us figure it out that which number is greater than which number. This is cube root of 2, or you can write it as 2 to the power 1 by 3. This one is square root of 3, this you can write it as 3 to the power 1 by 2. And this one is your 6th root of 5, that is 5 to the power 1 by 6. Isn't it? Now see, here you have power 1 by 3. You have power 1 by 2, here you have power 1 by 6. It is not easier for you to compare. At least the power should be same so that you can compare. If I say root 2, root 4 and root 16, which one is greater? This is root 2, 1.732. This is root 4, 2, and this is 16, it is 4. Which one is greatest? If the number inside it is increasing, as the number inside the root is increasing, the value is also increasing. So if I say cube root of 7, cube root of 14 and cube root of 100, which one is greater? Since the root is same, cube root and cube root, if the number is higher, the value will be higher. So cube root of 100 will be larger than cube root of 14, and this will be larger than cube root of 7. So if we have one root, it will be easier for us to find. Here we have different roots. One is cube root, then square root, then 6th root. So let's convert them into a single root or a single reciprocal of power. How can we do this? We can take the LCM of this denominator 3, this denominator 2, and this denominator 6. LCM of 3, 2 and 6 is what? 6. So how can we convert 1 by 3 into 6? We can multiply by 2 and divide by 2. It will be 2 by 6, isn't it? So you can write it as 2 to the power 2 by 6. Similarly, for 1 by 2, you can multiply and divide by 3. You will get 3 by 6. Three to the power 1 by 2 is 3 by 6. This is already 1 by 6. This is already 1 by 6. So here you have 2 by 6, power is 3 by 6, power is 1 by 6. You can write it as, isn't it, 2 and bracket and 1 by 6. Let's make this simpler for you to understand. You can always write a to the power m into n. What it becomes? A to the power m into n. 2 to the power 2 into 1 by 6. It will become a to the power 2 into 1 by 6 or 2 by 6, isn't it? Our motive is to get 1 by 6 as the power. Again 3 to the power 3 and 1 by 6. This is what? This is 5 by 6 only. 5 or 1 by 5 to the power 1 by 6 only. This will give you 4 to the power 1 by 6. This will give you 3 3 ja 9, 3 ja 27. 27 to the power 1 by 6. And from here you get 5 to the power 1 by 6. So this is what? This is the 6th root of 4. This is the 6th root of 27 and this is the 6th root of 5. Now you have a common root, that is the 6th root, and at this place you have number 4, here you have number 27, here you have number 5. Which one is the largest? This one is the largest. This number is the largest. This is the largest. This comes first in the exam. Then smaller than this. This one, number 5. This is at number 2. The first runner-up and the second runner-up. The second runner-up is this number or third one. So this is highest, this is after that, and this is the lowest. So in decreasing order, in descending form, what we do? Largest one is written first, then smaller than this, then the smallest. So larger one is root 3. Then this number is what? Greater than. There are two parts. One is this arrow head and another is this broad portion. So whichever number is greater hits arrow over the smaller one. The pointing of arrow, this will directly go to the stomach of the next number which is smaller than this. So the next number is this 6th root of 5, and this will again discriminate its junior, point arrow towards it, and its junior is root 3 by 2. So in this way you have got the solution. Smallest, then a smaller, then largest, then smaller, then a smallest. So this is descending. If you were asked to write it or arrange it in ascending order, it will be the opposite of it. First you will write cube root of 2. It is a smaller one. The larger one will be hitting arrow on it. Clear? This is your ascending order, and this was your descending order. Clear? Question number 12 is done. Question number 13. Question number 13 you can solve it easily. I think you can solve it by looking at it also. But for your exam purposes, for getting marks, you don't have to solve just in your mind, but you also have to write. So 1 cube plus 2 cube plus 3 cube to the power 1 by 2, and you have to evaluate this. 1 cube is what? 1 to the power anything is 1 only. 2 cube, 2 to the 4 to the 8. 3 cube, 3 3 is 9, 3 is 27, and to the power 1 by 2. This is what? 27 and 8, 35, and 1, 36. 36 to the power 1 by 2. That is, it is what? It is the square root of 36. So, what numbers when multiplied by itself gives 36? 6. You can write it as 6 square. 2, 1 by 2, cancel out each other. 6 to the power 1, that is 6. This you can prime factorize and get 6 square. Thirty-six, 2, 18, 2, 9, 3, 3, isn't it? So it is made of 2 2s and 3 3s. So 2 into 2 into 3 into 3. If you make a pair of this 2 and 3 together, 2 into 3 and 2 into 3, what you get? 2 into 3 a square, that is 6 square. So when you write it as 6 square and this powers will multiply and 2 will cancel 2, you will have 6 to the power 1 only, and that is 6. And this way you can evaluate and the value will be 6. Question number 13 is also done. We have solved 13 questions within 1 hour and 26 minutes. Question number 14, and we have understood some concepts of earlier classes as well within this time. So let's see the next question, question number 14. These are question number 14 and 15 which we will solve right now. Question number 14 says 5 into bracket. We are taking 8 to the power 1 by 3 plus 27 to the power 1 by 3. 3 over the bracket and all these inside the square bracket with exponent 1 by 4. So we can solve this. This is a number, there is no x or y, there is no x, y. You can simply find this, find this, find this. What is the best approach to solve this? 8 and here it is 3. Can you see something, some relation between this and some relation between this? This can be written as 2 to the power 3, isn't it? Similarly, this, you have seen so many examples, you have solved so many questions over here in this video. This can be written as 3 to the power 3 as well, as you have studied in so many questions today only. Just copy down the remaining things. Maths is such an easy subject. This 3 will cancel, this 3 will cancel each other. You will get what? You will get 5 and 2. 2 into 3, 2 plus 3, that is 5. And this bracket had a power 3. So this power will come here. Power 1 by 4. See, this 5 has a power 1 and this 5 again has a power 3, and both are getting multiplied. So 8 to the power m into 8 to the power n, the powers will multiply. It will become 1 plus 3, that is 4. 1 by 4. Now these powers will multiply because power of power gets multiplied. 4 cancelled. You have 5 raised to the power 1, that is 5. So you have evaluated this. Question number 14 is over. Heading towards question number 15. Question number 15 says cube root of 2 multiplied by 4th root of 2 multiplied by 12th root of 32. This is 2 to the power 1 by 3 and this is 2 to the power 1 by 4 and this is what? 32 is what? That 32 is 2, 16, 2, 8, 2, 4, 2, 2. Isn't it? 2 to the 4 to the 8 to the 16 to the 32. 1, 2, 3, 4, 5. 2 to the power 5 is already there, and 12th root. So this is 2 to the power 1 by 3, this is 2 to the power 1 by 4, and this is 2 to the power 5 by 12. Same thing. Base will remain same, powers will add up. 1 by 3, 1 by 4, and 5 by 12. This will become 2 to the power. LCM of 3, 4 and 12 is 12. Because 3 can also divide 12 perfectly, 4 can also divide 12 perfectly, 12 can divide 12 perfectly. And this is the smallest one that can be divided by 3, 4 and 12 perfectly. So this is the least common factor, or this is the this least common multiple, or LCM. 3 4 ja and 4 1 ja. 4 3 ja and 3 1 ja. 12 1 ja and 1 5 ja. So how much it is? 2 to the power 4 plus 3, 7 plus 5, 12 by 12. 12 by 12 is 1, is 2. Isn't it? This way question number 15 is also done. Next question, question number 16. Moving on to question number 16, let this open. This is your next question. Square root of x to the power minus 1 into y, square root of y to the power minus 1 into z, square root of z to the power minus 1 into x, and you have to prove that this is going to be equal to 1. So take this as your LHS, like we do whenever we are given to prove this equal to this. So taking this as LHS, you do not have any square root or anything here. You have power as minus 1, you have also a square root. So it is always better to remove this square root. So remove this square root. This is 1 by 2. This is 1 by 2 minus 1x. This is 1 by 2. This x minus 1. This will get 1 by 2. Y will also get its 1 by 2. Y, it will get its 1 by 2. Z will also get its 1 by 2. This z to the power minus 1, this will get its 1 by 2, and this x will also get its 1 by 2. This is what? This is x to the power minus 1 by 2. This is y to the power 1 by 2, z, y to the power again minus 1 by 2, z to the power 1 by 2, z to the power minus 1 by 2, and x to the power 1 by 2. Here you have x to the power minus 1 by 2, here you have x to the power 1 by 2. So x to the power, you can arrange it like this, and later on you can, since the base are same, powers will add up. So base are same, powers will 1 by 2 plus minus 1 by 2, and this will be minus 1 by 2. Similarly, y 1 by 2 and minus 1 by 2, z 1 by 2 and minus 1 by 2. Anything being subtracted from itself. I give you 5 apples and take back the 5 apples. What you are having? You are having 0 apples. X to the power 0, y to the power 0, z to the power 0. So x will become 1, y to the power 0 is also 1, and z to the power 0 is also 1. 1 multiplied by itself 3 times, it's 1. This is your RHS that was required to be proved, and you have proved it. This was your question number 16, and you have solved this also. Now we will move towards we have the next question as question number 17. It says x to the power 1 by a minus b by 1 by a minus c, x to the power 1 by a minus b to the power a by 1 by b minus a, and x to the power 1 by c minus a, and that to the power 1 by c minus b, and you have to prove that that is equal to 1. So you will begin with your LHS. Power of power multiply a minus b into a minus c, x power of power multiply b minus c into b minus a, power of power multiply, that is c minus a into c minus b. Okay, now a to the power m, a to the power n, a to the power k, the bases are same, powers will add up. You can simply add it. X to the power 1 by a minus b, a minus c, plus 1 by b minus c, b minus a, plus 1 by c minus a, c minus b. A minus b, a minus b, here it is b minus a. You can convert this into a minus b, it is b minus a. If you take out minus common, you can write it as a minus b, it will be minus a plus b, minus a plus b, isn't it? So you have to take minus 1 common. If you take minus 1 common, this minus 1 will come over here and make this minus, and it will give you the liberty of writing it as a minus b. Clear? So a minus b here, a minus b here, a minus c is here, c minus a is here. And here b minus c, here c minus b. So let us take denominator as a minus b, b minus c, and c minus a. If you convert it into b minus c, again you will get minus here, and this will be converted into b minus c. In your notebook or copy or in exam hall, you do not just simply convert it, write it in the next step. So this is, you have got a minus b, you have got a minus b here, a minus b here, b minus c here, b minus c here, a minus c, you have to obtain c minus a, so you have minus a, you have obtained here, a minus c is here. So you can again take minus sign common, and this will be your minus 1, or minus over here you can also take, and this will get converted into c minus a. Now you have, for this can divide this, yes, it has a minus b, c minus a, and that's it. It has a minus b, c minus a. It will multiply, if you multiply b minus c, you will get this number. So this number is b minus c times this number. No, isn't it? This number is b minus c times this number. So b minus c will multiply with minus 1, b minus c. Okay, minus. B minus C is here and A minus B is also here. C minus A. This will divide this part C minus A times, or this is multiplied by C minus A, you get this denominator. So this number is, so this denominator is C minus A times of this number. C minus A you will write here, C minus A multiplied by 1. In this case C minus A is there, B minus C is there, only A minus B is not there. So A minus B you will write. Now see what happens. X raised to the power, this will be your A minus B, B minus C and C minus A. Minus B, open up the brackets, minus B plus C, minus C plus A, minus A and plus B. Plus B minus B cancel each other, minus A plus A cancel each other, and your plus C minus C cancel each other. So you get x to the power 0 by A minus B into B minus C into C minus A. See, 0 by anything, 0 by 7, 0 by 292, 0 by anything is 0. Dividing 0 by any number gives you 0. So 0 by this number, B minus X minus A, B minus C, C minus A, this will be 0. X to the power 0, and anything to the power 0 is 1. Anything to the power 0 is 1. And this is what your RHS that you needed to prove, and here you have proved. This is one that you have got. So question number 17 is also done. Question number 17 is also done. This is your next question. Question number 18, x to the power b by x to the power c, and it is power b plus c minus a. Again x to the power c by x to the power a, c plus a minus b, and again x to the power a by x to the power a, x to the power b, x to the power a by x to the power b, and power is a plus b minus c. Whatever it is, b and c are there, both add up, and which is not present, b and c are there, a is not present, so a is minus. Here c and a are there, c and a are added. What is not present? B is subtracted. Here we have a and b is added and c is subtracted. This is your question, and the question says x is a positive real number. X is any positive real number. The question also gives you exponents are rational numbers. So there is no any benefit of giving this, because you can the only thing that you conclude from this, that you can easily apply the law of exponents over here, because while I was giving you the class on laws of exponents, I told you these all laws are applicable. Any of these law can be applied when you have x as real number and the exponents whatever I was using were a rational number. In this case, laws of exponents can be applied. So this is nothing but just to give you that you can apply laws of exponents in this question and we are already solving questions using laws of exponents, so no extra benefit you are going to get with this additional information what has been given to you. Let us solve it like we are solving the questions. So here what do we observe? See, x power b and power c, so it will be power b minus c, and it is b plus c minus a. Again x c minus a, from here, and c plus a minus b. Again x a minus b and a plus b minus c. Is it? This will give you x. Together you can add it. So you get b square, b, first do it with b square bc minus ab minus bc minus c square and plus ac. Similarly here also x c square, c, first do it with c then with a, c square plus ac minus bc minus ac minus a square and plus ab. For this x, a square plus ab minus ac minus ab minus b square and plus bc. ab cancelled, ac cancelled, and bc cancelled. Moreover, x to the power m into x to the power n, you can add up x to the power m plus n. So you can add it. Similarly, you have x to the power m into x to the power n into x to the power k. It will be, base will remain same, exponents will add up, m plus n plus k, isn't it? So base we have x only, and so we will add the powers. Powers we have b square minus ab minus c square plus ac. From here plus c square minus bc minus a square plus ab. From here plus a square minus ac minus b square plus bc. b square and minus b square, a square and minus a square, c square and minus c square. Again minus ab plus ab minus ac plus ac minus bc plus bc. You find anything that is not cancelled out? There is nothing. Everything gets cancelled out, and we get x to the power 0, and x to the power 0 is 1. So we get 1. So we have solved question number 18 also. In the same case, you can be asked that prove this is 1. So you will begin with LHS, go to RHS, you go to your answer 1 and write equals to RHS, hence proved. (19). This is your last question. 9 to the power n into 3 to the power 2 into 3 to the power minus n by 2 to the power minus 2 minus 27 to the power n divided by 3 to the power 3m into 2 to the power 3, and that is equal to 1 by 27. That is given. You don't need to prove it. You need to prove what? You need to prove m minus n equals to 1. So we will solve this, and in the mid course we will get this. This is your 3 to the power 2. Everything is given in 3, so it's better you convert it into 3 or 2. 9 cannot be converted into the form of 2. So let's convert it into the form of 3. 3 to the power 2 and n. From here, and it is 3 to the power 2, again 3 to the power minus n by 2 into minus 2. This 2 gets cancelled over here. Minus 27 can be written 3 to 3 is 9, 3 is 27, 3 to the power 3 and this n. Denominator 3 to the power 3m into 2 to the power 3. You find what? This minus and this 2 is cancelled, but minus 1 is still there. Minus minus plus 3 to the power 2m, 3 to the power 2, 3 to the power n minus 3 to the power 3n divided by 3 to the power 3m into 3 to the power 2 to the power 3. Only 2 is only at this place. At other places 3 is there. You see what we have here. 2 to the power 2n and 2 to the power 3 to the power 2n and 3 to the power n. Powers will add up and make it 2 to the power 3n and 3 to the power 2 3 to the power 2n and 3 to the power n. This is 3 to the power 3n. What is left? 3 to the power 2 minus 3 to the power 3n divided by 3 to the power 3m into 2 to the power